How's it going, everybody? So today we're going to be talking about factoring polynomials, and this kind of notes is going to be a little bit longer than what we typically do just because there's a lot to really unpack in factoring these different polynomials. Now, there is going to be some review in the sense that when we factor polynomials, the AC method is embedded in a couple of these, but there is going to be a couple of new things that we will have to hit on. So let's first start off with when we factor out a common factor, which then prompts us to factor using the AC method. So if you are given a situation where you have three terms, okay, so you have a x cubed minus a 4x squared minus a 5x, something like this. The first thing you need to understand is that this looks very similar to what we've been doing with quadratics, but we now have a cubed, right? And so what we need to go ahead and do is factor out a like term to get it to that quadratic state, so that way we can go ahead and do our AC method. So I notice they all have an x in common, and so I factor that x out and I have an x squared minus a 4x minus a 5. Now, this middle part inside is officially what we're used to seeing and working with, and we can now do the AC method on it. Now, we're doing it based off of the -5, and the multiples of -5 that give me a -4 are -5 and a +1. So then I would have x squared minus 5x plus x minus 5. And I would go ahead and factor that, and I would have x minus 5, x minus 5 on the right, and then of course I would have a +1 right here. Now, I then create my factors, x minus 5, x plus 1. Now, we cannot forget about this guy that was attached to it at the very beginning. He's going to come down with this and be x, and then x minus 5, x plus 1. This right here is actually a fully factored polynomial, okay? So this is fully factored because I can tell where all the x-intercepts are. I can tell that I have an x-intercept at x equals 0, as well as at x equals 5, and an x-intercept at x equals -1. So I actually have three instances where this graph will cross the x-axis, okay? So let's take a look at another one. Say I give you something like this, a 5z to the 4th power plus 30z cubed plus 45z squared. So looking at this right here, I see that they have a z squared in common. So I'm going to take a z squared out, and that's going to leave me with 5z squared plus 30z plus 45. But I also want to go the extra mile and see that they're also divisible by a 5. I could take a 5 out too. So I have 5z squared, and then I have z squared plus 60z plus 9. And so now that's a lot easier to do my AC method on. So the AC on 9 would be 3 and 3. So I would have z squared plus 3z plus 3z plus 9. And then I have a z in common, so I'd have z plus 3. Z plus 3 will be over here as well, and a 3 in the front. So you end up with z plus 3 twice. And then, of course, you can't forget about what we originally took out up here, right? And we're going to take the whole 5z squared. So that 5z squared comes on down and is a part of our official answer. So this means right here, these would represent my x-intercepts. So I'd have a 5z squared equal to 0, and then a z plus 3 equals 0. Now, I only have to do it once for the z plus 3, because I have just, it would just be 2 of the same. So z equals -3, and then in the end, this would just be z is equal to 0 over here. So I would have two instances where the graph would touch the x-axis, and those would be my x-intercepts, okay? Now, sometimes, though, we will get into things that will not necessarily be three terms, okay? Sometimes we'll experience things that have 4 terms now. So let's take a look at that. We have a y cubed minus a 5y squared plus a 6y minus a 30. if you experience a moment where you have 4 terms, okay, and when I'm talking about terms, I'm talking about 1, 2, 3, and 4, okay, then you're going to do a process called factor by grouping, okay? So if you need to, off to the side, maybe label this as grouping, okay? Now, when you do factor by grouping, what you'll notice, it's pretty much the AC method. All I'm going to do factor by grouping is split it down the middle. I group it into 2 sides, group 1, group 2. And so you're looking at that going, how's it any different than what we just did? It's not. There's nothing different. And we just basically continue the same. We see that there's a y squared in common. So I have y minus 5. So that means I have y minus 5 over here. And so that's going to go ahead and give me a 6 in the front. So I have y squared plus 6. And then I have a y minus 5. And so this right here would represent the factors. And if you wanted to, you would just go ahead and, put them equal to 0 to solve for x-intercepts and things like that. So let's go ahead and do another one of these. I have x cubed plus 3x squared minus 7x minus 21. So once again, we have 4 terms, so we're going to go ahead and split that down the middle. I see that I have an x squared in common, so then I have x plus 3. And so I'll end up with x plus 3 over here. Now, what goes in front? Negative 7. And now I have x squared minus 7, x plus 3, and then you're done. Arguably, factor by grouping kind of sets you up for some success because there's not too much involved. You just split it down the middle and you figure out what they have in common, and that ends up being your factors. It very much is like the AC method. Now we're going to move away from the AC method and grouping, and we're now going to go ahead and talk about a method called the sum of 2 cubes, okay? So sum of 2 cubes, okay? Now, the first thing you have to understand about the sum of 2 cubes is the formula, okay? The formula says that if you have an a cubed, some number is a, okay, and a b cubed, another number, then you're going to end up with a plus b, and then you'll have a squared minus ab plus b squared, okay? Now, an example of how that looks is going to be something like this. So say you had a 64x cubed plus 1. Now what I'm going to do is start taking this thing called a cube root, okay? So in order to do a cube root, there is a way to do it in your calculators, and you're going to have to just play around with the calculator that you have or look up how you can perform the cube root on it. If you need me to walk you through how to do it on your specific calculator, just let me know which one you got and I can tell you how to do it in class. But we're going to take the cube root of 64x cubed, and then we're going to do the cube root of 1. Now, believe it or not, doing the cube root can also be done by hand, okay? And I'll show you how that works. You're going to do the factor tree once again, okay? Now, 64, you can break it up into 8 times 8, right? And then not only can you do that, but you can break up 8 into 2 and 4, 2 and 4, 2, 2, 2, 2. Now, what's interesting about cube roots is in order to leave a cube root, you have to have 3 of a kind. So here's 1, 2, 3, 1, 2, 3. So I have 2 sets of 3. So I'm going to go ahead and say that that right there is a 2 and a 2. Now, the x cubed is also we're taking the cube root of that as well. Now, there's 3 x's, so that means one of the x's get to leave, and you end up with a 4x, okay? So the cube root of that is the 4x. And this right here, by the way, is your a. So this is a, and then this is going to represent b. Now, the cube root of 1 is actually just a 1, because technically, the way the factor tree would talk about it is you can say 1 is 1 and 1, and then you'd have 1 and 1. And honestly, it looks like a stick figure by the time you're done with it. But the idea is that you would end up with 3 1s, okay? And so that's why the cube root of 1 is still 1. Now, you're going to plug your a and your b into the formula, and so you'll end up with 4x plus 1, and then you're going to go ahead and have 4x squared, okay? And then you'll have yourself a minus 4x times 1. And then let me kind of shrink that a little bit. And then a b value, right? 1 squared. So we're going to go ahead and simplify that. We have 4x plus 1. Now 4x squared, that's going to give you a 16x squared. And then a 4x times a 1 is a negative 4x. And then a 1 squared is just a 1. And so this right here, ladies and gentlemen, is your answer to this example, okay? So the biggest things, the biggest takeaways is make sure that you take your a and your b value and you do the cube root over here, okay? Do the cube root on both of those values and then you're good to go, okay? So that is the sum of two cubes, okay? And we could also do another one. All right, here's another example. We have ourselves a 16 s to the 5th power plus 54s squared. So looking at this right here, ladies and gentlemen, we see that there are some things in common that we could take out before we start doing the formula. And just a reminder, the formula is a cubed plus b cubed is equal to the a plus b. And then you have a squared minus ab plus b squared. Okay. So we're going to take out an s squared because they have that in common, as well as a 2, because 16 and 54 are both divisible by 2, and that would give me an 8s cubed. 54 divided by 2 is a 27. And so there we go. Now these guys right here on the inside represent a and b. So I have my a is the cube root of 8s cubed, and b is represented by the cube root of 27. Now you can do it on the calculator, but we're going to do it by hand. So 8 you can break up into 2 and 4, 2 and 2. And so conveniently, as you can see, I have 3 of a kind, so the 2's get to leave. So I have 2, using a highlighter, 2, and then of course there's 3 s's, so an s gets to leave. Now let's look at 27. So 27, that's a 3 and 9, 3 and 3. Once again, conveniently, I have 3 3's. So a 3 gets to leave. So all I have to do is plug in that information into my formula, and then I'm good to go. So I have 2s plus 3, and then I have 2s and then squared minus 2s times b, which is 3, plus b squared, which is 3 squared. Okay, so I got to simplify that. So I have 2s plus 3, and then I have 2 squared, that's 4s squared, that's s squared. Negative 2s times 3, that's negative 6s, and then 3 squared is 9. And now we can't forget about one little detail though. This guy up here. We took out some like terms and we got to bring him on down to be a part of the answer. And so we have a 2, let me see if I can shift this over a little bit, 2s squared. Okay, and so that right there, ladies and gentlemen, that's the full answer. It's easy to forget about him. I have even forgotten about what I sometimes factor out, and so you just got to make a concerted effort not to forget about the very beginning of the problem, okay? And so there you go, guys. Now let's talk about the difference of two cubes. So the difference of two cubes, okay, let's actually go ahead and title it difference of two cubes. We have ourselves this formula. A cubed minus b cubed is equal to a minus b. And then we have a squared plus ab plus b squared. Now, the same principles, okay, we're still going to be doing the cube root and stuff, but now you just have a minus. So we have our 27x cubed, this is an example, minus 8. Now, looking at this right here, there's nothing that they have in common, so I'll go ahead and start taking the cube root. So a is equal to the cube root of 27x cubed, and b is equal to the cube root of 8. Don't do negative 8. I know it seems like the sign should go with it, but just trust me, just leave it away, leave it off. And so let's go ahead. We know the cube root of 8 is actually 2, right? Because we did the factor tree a while back, and it breaks up into 3 sets of 2, or 3 2s, 1 set. Yeah. And so we know that 27, we know breaks up into, the cube root of 27 is a 3. And then, of course, the x cubed, that's just x. So we're going to go ahead and plug these values in. So we have ourselves a 3x minus 2. And then we have our 3x squared plus 3x times 2, and then plus 2 squared. So I have 3x minus 2. Now, 3 squared, that's 9, and then x squared. And then I have my 3x times 2, that's a 6x, and then 2 squared is 4. And so right there, ladies and gentlemen, that is the answer to this example, okay? Now, there's nothing to add to the very end of it because we didn't factor anything out, okay? So this one's good to go. So let's take a look at another example. So say we had something like this, x cubed minus 125. Just to reiterate, a cubed minus b cubed is equal to a minus b. Then you have a squared plus ab plus b squared. All right. So let's go ahead and take the cube root of x cubed, and that's our a, and I should go ahead and maybe scoot that over so I can write it. And then b is equal to the cube root of 125. So I end up with x, and over here I end up with a, now the cube root of 125, I guess we could go ahead and figure that out. 125. You could break that up into 5 and 25. And 5 and 5. And so conveniently, I end up with three 5s, so I can pull a 5 out. So I plug it into the equation. I have myself a x minus 5, and then I have an x squared plus x times 5, so that's just a 5x. And then a 5 squared, that's just a 25. And so that right there is my answer. And so there you go. So that right there is the sum and difference of two cubes. And we only have one more thing to talk about. We need to talk about the difference of squares, okay? Now, there's only the difference of squares. There's not the sum of squares, okay? So we only have one more thing to go over. So the difference of squares. So the difference of squares, the formula is a squared minus b squared is equal to a plus b, a minus b, okay? And so let's look at the example that I have for you. Say you have something like 16x to the fourth minus 81. So what you're looking for is you're looking for basically an even power and the fact that you can take the square root. So normally when we were looking at the difference of cubes, we saw that they were cubes, that they were odd powers. But with the difference of squares, you're looking for even powers, okay? So here we have an even power, and in order to do it, we have to go ahead and take the square root to find the a and the b. So for a, we're going to do the square root of 16x to the fourth, and then we're going to do the square root of 81. Now, the square root of 16 is 4, and then the square root of x to the fourth is x squared. Now, you might be wondering, how in the world does that make sense? Well, if you look at x to the fourth and you do a factor tree on it, that's like saying x squared. Well, if you have a pair of x squareds, that's what this is. You got to leave. Now, the square root of 81, that's 9. And now you just plug in the formula. So you have yourself a 4x squared plus 9. 4x squared minus 9. And that's all there is to it for that one. So guys, the difference of squares is pretty straightforward. It's very much like the sum and the difference. And we'll do more examples in class and things like that. But that's the general idea. It's very similar, so I won't go over too many more examples. I think that's pretty straightforward. So guys, we'll go ahead and get started on the work. And if you need anything, let me know. Good job, guys.